here we have our science critic, and he's going to talk about predictions, but he's going to talk about the accuracy of predictions. Let me put this fellow on so you know what his argument is. Here goes. Listen carefully.
The questions and issues to be addressed in this rebuttal include: is guessing which horse is going to win the race a part of science? And if a prediction materializes, does that confirm the physical interpretation of the phenomenon?
With predictions, it doesn't matter whether it's a description or an explanation. The point of predictions is to validate whether what you are testing is accurate or not. Let's take weather forecasting as an example. Let's say that you've got two different models. One says that it's going to rain, and the other says that it's going to snow. If it rains, then the one that says that it's going to rain is more accurate. If it snows, then the one that says that it's going to snow is more accurate. And if it does neither, then you're probably going to need a better model.
Okay, so let's go through the rundown with what this fellow said. He's got so many things wrong, it's hard to know where to begin. First thing, prediction is not an explanation. Okay, it's important to establish that because, well, I'll get to an example in a second here. Prediction is a description. If I say that tomorrow there's going to be an eclipse at 2 o'clock, all I've said is a description. I haven't explained why that's going to happen. If I can explain why it's going to happen, I'm going to give you an explanation. I'm no longer talking about the future. I'm not talking about a prediction. I'm talking about the past. I'm talking about something I had experience with or some contact in the past with. Okay, so as soon as you explain why a prediction is going to come true, you're no longer talking about the future. That's why prediction, just a statement, is nothing but a description. And that's important. But this fellow says, well, it's neither. We don't care about that, etc., etc. What does he say? He says accuracy. He says it either snows or rains. Well, we have the difference between physics and math now, because physics is qualitative. It either rains or it snows. Okay, it can't be both. Okay, so if it snows, it didn't rain. If it rains, it didn't snow. It's a black and white issue. But this fellow puts talks about accuracy. And so, here's an example for accuracy. Okay, we're going to get a pencil. Going to do my famous experiment, $1 million experiment. We let go of the pencil and it falls to the floor. Now, it either falls to the floor or it don't. It's one or the other. It can't be both. Okay, so it either falls or it don't. This fellow says, well, we don't care about that, the black and white kind of stuff, yes or no. No, he cares about how fast does it fall. Like, what is the acceleration? So he says 9.8 meters per second squared. Well, maybe it's 9.81, maybe it's 9.80, maybe it's 9.79, who knows? The point is, he's talking about accuracy, which is an issue of mathematics, has nothing to do with physics. Yeah. Physics is just black and white. Did it fall or not? Black or white? Did the eclipse happen or not? And the guy says, well, it happened at 2 o'clock and 1 minute in the afternoon. Like, that's accuracy. I can predict exactly the moment it's going to do it.
Close as they get, and we're just
but that's a mathematical issue.
You're saying it's 100% or it ain't.
Yeah, so we have a difference first between physics and math. That's one issue, and we don't care about math. We're talking about physics here. And then the other thing is, he says, a model that predicts, that's just a description. Because again, if you're just going to predict, you're not going to tell me why. And if you can tell me why, you're no longer predicting. Now you're talking about the past, about something you already have experience with.